We are told that f is a continuous and differentiable function. That's pretty important. It's a continuous and differentiable function. That means we can differentiate it. If we take any point on here, we would be able to find its derivative. And we're given selected values of f in this table right here. And we're asked to find the approximate value of f prime at x equals 1. So we're looking for the derivative roughly of this point. That's the target that we're taking a look at. And we know we can find its derivative because it is a continuous and differentiable function. But here's the problem. I don't actually know what f of x is. So I can't just take some formula and differentiate that formula. I don't know what that formula is. So I can't actually do this. This method is actually not going to work. So we're going to have to approximate this derivative. Now, there are multiple answers that you could do in a situation like this, but probably the most correct is to pick points that are near. So I'm going to go ahead and indicate with little dots what 2 points I'm using. There are 3, I think, most appropriate solutions. So one is each dot represents the 2 points, the same color represents the 2 points I'm using. So we could use points x equals 1 and x equals 2. We could use points x equals 1 and x equals 0. And we also could use points x equals 0 and x equals 2. Any of those points, I think, would also give us a good approximation of this derivative. So let's go ahead and see what would those be. Well, we're given 2 points. We're given a line. Remember, if we look at this graphically, we're trying to find f prime of x, f prime of 1. That's going to be the slope of some tangent line at x equals 1. So we're looking for the slope of a tangent line. But if we're given 1 point on that line, we can't find the slope. So we're going to approximate using a secant line where we're given 2 points and we can find the slope. So let's go ahead and start. We can approximate that f prime of 1 is approximately, let's see, we're using the points 2 and 1. So it would be y2, which is f of 2, minus y1, which is f of 1, over 2 minus 1. And that's going to go ahead and give us, well, f of 2, that ends up coming out to be 2.08 minus f of 1 is 1.59 over 2 minus 1. That's going to get us, if we want to refer to our calculator to give us an answer, we can go ahead and put in 2.08 minus 1.59. And that gives us 0.49 over 1. Or we could say that is 0.49. Or we could even round it and say, yeah, that's approximately 1/2. So if we use 2 and 1, if we use the points x equals 2 and x equals 1 to approximate the derivative, we get a slope of that. We could also use a different set of 2 points. We're going to use x equals 0, f of 0, and f of 1. So we're going to do y2, in this case is f of 1, minus y1, which is 0, over x2, which is 1, minus x1, which is 0. And if we compute that, we're going to get, well, f of 1, that is 1.59, and f of 0, that's 1 over 1 minus 0. And that's going to give us simply 0.59 over 1, or 0.59 as our approximation of the derivative. We could also even round that to 0.6. So, looking at the pattern like this, we could probably guess what f prime of 1 is when we use the 2 points surrounding it, based on our knowledge from the last video, which was it was the average of these two, but let's see if that roughly holds up to be true. So our y2 is going to be f of 2, our y1 is going to be f of 0, and x2, which is 2 minus x1, which is 0. F of 2, we're given as 2.08 minus f of 0, which is 1, over 2 minus 0, which is going to get us 1.08 divided by 2. And if you want to use your calculator to go ahead and calculate that, I wouldn't blame you. We take out our calculator, find that it gives us 0.54, 0.54 as what we get. And out of curiosity, let's just see what happens if we find the average of these two values. Is that going to give us 0.54? 0.49 plus 0.59 divided by 2. And sure enough, it gives us 0.54. But either one of these would be an acceptable answer. Any one of these three would be an acceptable answer for the approximation of f of prime at x equals 1.